Okay, hello, precious one. I welcome you once again to Kenyako Mathematics Classroom. On this particular episode, I'll be teaching you sequence and series. I'll be teaching you sequence and series. So, guys, we have sequence and series. Now, I will advise that if you have not subscribed to the channel, you subscribe to the channel Kenyako Mathematics Classroom, so that anytime you drop a video, you can get the presentation or the alert. You press on the notification bell so that when you drop any video, you can get the alert. You can also share the presentation to somebody who may need such topic. Now, we are looking at sequence and series, and we are going to look at the general idea of sequence and series. Now, I will also advise that you get your book, you get your pen, maybe you get your calculator so that you can follow me on the presentation, because mathematics, you need to be practical, so you need to work it out yourself. Now, we are looking at sequence and series. And when we talk about sequence and series, what are we talking about? Now, when we say sequence is the arrangement of numbers in a particular order. That is all. And when the terms of the sequence are added together, we have what we call the series. Now, I'm going to explain. Now, first, we are saying that sequence is the arrangement of numbers in a particular order. Now, let's assume we have the sequence. We have 2, we have 4, we have 6, we have 8. And this is the sequence. Now, when the terms or when numbers are arranged in a particular order, we call it the sequence. So this is an example of a sequence. Very soon I'll be explaining to you the types of sequence you are going to consider as far as sequence and series is concerned. Now, when you look at this is an infinite sequence because the last term is not known. So when the terms of this sequence are added together, then we have what we call the series. So if you have 2 plus 4 plus 6 plus 8 plus, because the last term is not known. So this is what we call the sequence, and this is what we call the series. So the sequence is the arrangement of numbers in a particular order. And when the terms of the sequence are added together, we have what we call the series. So this is an infinite sequence because the last term is not known. And this is an infinite series because the last term is not known. Assuming that the sequence was 2, 4, 6, and 8. This is a finite sequence. This is the first term, second term, third term, and the fourth term. Because the last term is known, it's a finite sequence. Now, if you want to generate the series, we only add the terms of the sequence together, and this is what we call the series. This is a finite series because the last term is known. This is a finite sequence because the last term is known. This is an infinite sequence because the last term is not known. And this is an infinite series because the last term is also not known. And so, in general, that is what we mean by sequence and series. Now, let's consider something. We are going to consider types of sequence. So, we are going to consider types of sequence. And the types of sequence we are going to consider here is what we call the arithmetic progression. We also call it the AP, or the linear sequence. Then 2, we also have geometric sequence. And with the geometric sequence, we also call it the GP, or it's also known as the exponential sequence. We have other types of sequence, but in this particular level, we are looking at arithmetic progression. That's the linear sequence, also known as the AP, or the geometric sequence. That is what we call the GP, or the exponential sequence. So now we are going to look at what we call the arithmetic progression or the linear sequence. That is the arithmetic progression. That is the AP. This is the same as the linear sequence. Now, a sequence is said to be a linear sequence if it has the same common difference. That is all. So, A sequence is said to be an arithmetic progression or a linear sequence if only it has the same common difference. Now, let's consider an example. Let's assume you are given the sequence 2, 4, 6, 8, and this is an infinite sequence because the last term is not known. It continues like that. Now, the first term is 2. These are the terms of the sequence. This is the first term, the second term, the third term, the fourth term in that order. So the first term is 2, the second term is 4, the third term is 6, and the fourth term is 8. Now, with this, we can see that it has the same common difference. How do we find the common difference? You can see that the difference between the first term and the second term is 2. The difference between the second term and the third term is 2. The difference between the third term and the fourth term is 2. So it follows a particular order. It follows the particular order, and it has the same common difference. So when a sequence has the same common difference, then we term that sequence arithmetic progression or the linear sequence. Now, so here we have the first term. The first term is A. So the first term is A. Now the common difference is D, and the common difference is the second element minus the first element, and this is equal to 2, or is the same as the third element minus the second element, that is 4, and this is the same as 2, or is the same as the fourth element, 8, minus the third element, 6, is still 2. So you can see that it has the same common difference, and the common difference is 2. So if a sequence is behaving like this, then we call that type of sequence a linear sequence or an arithmetic progression. So any sequence that has the same common difference is termed arithmetic progression or the linear sequence. Take note of that. Arithmetic progression or the linear sequence. Don't forget that still we are under the linear sequence. We are now looking at the linear sequence. Now, we have, let's consider the nth term. We have the nth term of a linear sequence. Now, I guess you understand what is really happening. We are now under, we are still considering the arithmetic progression or the linear sequence. When we are done with that, then we also consider the geometric progression or the exponential sequence. But for now, we are looking at the arithmetic progression, and we are saying that a sequence is said to be an arithmetic progression or a linear sequence if it has the same common difference. Now, you have seen that the first term is represented by A. The common difference, this is how we calculate it. The second element minus the first element, the third element minus the second element, or the fourth minus the third. Each one will give you the same common difference. So if a sequence has the same common difference, then it means that that sequence is a linear sequence or an arithmetic progression. So now, let's look at the nth term of a linear sequence. Now, the nth term of a linear sequence is given by un equals a plus n minus 1 times d. This is the formula for finding the nth term of a linear sequence. Now, take note that the a is our first term. The a is our first term. N is the number of terms. And D is what we call the common difference. D is what we call the common difference. So this is the formula that we are going to use in finding the nth term of a linear sequence. When we say linear sequence, it's the same as arithmetic progression. And I guess by now you understand what we are talking about. Okay. So now the nth term formula of a linear sequence is un equals a plus n minus 1d. Now, defining the terms, we are saying that a is the first term. That is the first term of the sequence. N is the number of terms. And d is the common difference. Now, we are going to look at how to apply this formula. Let's look at how best we can apply this formula. Let's assume that you have to find the seventh term. The seventh term of the sequence. of the sequence 2, 4, 6, 8. So we have to find the seventh term of this particular sequence. Now, when you look at the sequence, let's see how best we can solve that. The sequence is 2, 4, 6, 8. So when you are given the sequence, some of the questions you will not be told whether it's a linear sequence or an exponential sequence. So you have to look at it. If it has the same common difference, then it is a linear sequence. And therefore, you know the formulas that you are supposed to use. But now we are looking at the nth term of a linear sequence. We are saying that un equals a plus n minus 1d. Now, when you look at this, you realize that it has the same common difference. The difference between the first element and the second element is 2. The difference between the second element and the third element is 2. And the difference between the third and the fourth element is 2. So it has the same common difference. So if you are trying to get the other terms, when you add 2 to 8, you are getting 10. When you add 2, you are getting 12. When you add 2, you are getting 14. Now, from the question, you have to find the seventh term of the sequence. So this is the first term, second term, third term, fourth term, fifth term, sixth term, and the seventh term. So the seventh term is 14. But sometimes you can be asked to find the 11th term or the 20th term, and you cannot be doing that by adding the common difference. And that is why the formula is there. So the formula is un equals a plus n minus 1 times d, where a is the first term. And so the first term, that's the first element of the sequence. The first term is 2. You can see that from the question. The common difference, d. Now you know how to calculate for the common difference. It's the second element minus the first element. That is 4 minus 2. And the answer is 2. Or you can use 6 minus 4. You still get 2. Or 8 minus 6. You still get 2. Now don't forget that n is equal to 7. How did you get the 7? It's from the question. From the question, you have to find the seventh term. And the n is the number of terms. When you were defining the terms, n equals the number of terms. So once you have to find the seventh term, that means that n is equal to 7. So now U7, we are now obeying the formula, equals a plus n minus 1d. A is 2 plus n minus 1, and n is 7. So you have 7 minus 1 times d, and d common difference is 2. So we have 2. Now this is 2 plus 7 minus 1 is 6. We have 6 times 2. 2 plus 6 times 2 is 12. And so 2 plus 12 will give us 14. You see that you are getting the same 14. That's what I was talking about. That's the meaning. Because now that you know the common difference, when you keep on adding the common difference, you will get a number of terms. But you don't want to be doing that. And that is why the formula is there. So this is the formula for finding the nth term. Any number of terms of the sequence, as long as it's a linear sequence or an arithmetic progression. This is the formula for finding that. And so our answer is 14. And you can see that when we added the 2 to the terms, 1, 2, 3, 4, 5, 6, 7, the seventh term was 14. You see that we are also getting 14. And so that is how we solve problems like that. So the formula for finding the nth term of a linear sequence is given by un equals a plus n minus 1d. U plus un equals a plus n minus 1d. Okay, now let's assume that with the same sequence, you are asked to find the 20th term. The 20th term. That means that n will be equal to 20. So un will be a plus n minus 1 times d. Now, a, the first term, is still 2. The common difference is still 4 minus 2, and that is 2. But we have to find the 20th term. So n is equal to 20. So u20 will be equal to a. That's the first term, 2 plus n minus 1. So n is 20 now. So we have 20 minus 1 times the common difference, which is 2. And this is 2 plus 20 minus 1 is 19 times 2. And this is 2 plus 19 times 2 will give us 38. 2 plus 38 will give us 40. That means that the 20th term is equal to 40. So what is really happening is, now that you know the common difference, if you keep on adding the common difference to the 20th term, the answer will give you 40. We cannot be doing that, and that is why the formula is there. So this is the general formula for finding the nth term of a linear sequence. You will be solving a lot of questions And so you understand what we are also talking about. What we are talking about. Now let's take a look at another question. Let's take a look at another question. Let's assume that you are given the sequence 3, 6, 9. This is the sequence you are given. Okay, so let's add 12 to it. And you have to find the system. You have to find the system. Now, because we are still on a linear sequence, I guess when the sequence is given, is a linear sequence that we are given. But when we are done with the sequence in series, when you are given the question, you have to check whether the sequence has a common difference, the same common difference or not. Now, when you look at this sequence that you are given, the sequence is 3, 6, 9, 12. So you can see that the first term is 3, second term is 6, third term is 9, and the fourth term is 12. You can see that it has the same common difference. And the common difference is 3. Even without calculating, you can see that it is 3. That is difference 3. So here the first term is equal to 3. And the common difference is the second element minus the first element. That is 3. Or the third element minus the second element. 9 minus 6 will still give you 3. Or 12 minus 9 will still give you 3. So that is how we calculate the common difference. Don't forget, you have to find the system. That means n is equal to 6. Now the formula is un equals a plus n minus 1 times d. Now a is equal to 3, d is equal to 3, and n is equal to 6. So u6 is equal to a, that is 3 plus n minus 1, that is 6 minus 1, d, and d is 3. So you have u6 is equal to 3 plus 6 minus 1 is 5. So we have 5 times 3. U6 will be equal to 3 plus 5 times 3 will give us 15. And U6 will be equal to 3 plus 15. 3 plus 15 will give us 18. That means that the system will give us 18. Now, when you look at this, the common difference is now 3, you know. So if you add 3, this is 1, 2, 3, 4. These are 4 terms. If you want to find the fifth term, if you add 3 to 12, you are getting 15. That's the fifth term. If you add 3 to the 15, you are getting 18. And that's what we are getting. But we don't want to be adding, as I'm showing you here. That is why the formula is there. So that is the general formula for finding the nth term of a linear sequence. The nth term